let's solve this like we usually do. Let's divide 2 from both sides to get the trig function by itself. That's going to be the square root of 2 over 2. And then let's make a quick substitution. Let's let x be 2 theta. So now this is cosine of cosine of x equals the square root of 2 over 2. And we can evaluate this from known trig values. Right? Cosine of x equals the square root of 2 over 2. The square root of 2 over 2 comes up in those 45, 45 triangles. Right? Because the sides are square root of 2 over 2 and the hypotenuse is 1 in the unit circle. And we need to draw this where cosine is a positive square root of 2 over 2. So we know that all triangles drawn in the first quadrant are positive. All students take calculus tells us that cosine is going to be positive down here. You don't have to use that too. You could whittle it out by thinking, okay, this is going to be my adjacent. Hypotenuse is always positive. That's another way of figuring out where cosine is going to be positive and where to draw the triangles. So this is going to be a 45-degree angle, which is pi over 4, and then this is going to be, let's see, 45 less than 360. So 2 pi subtracted by pi over 4. That's 8 pi over 4 subtracted by pi over 4. So this is 7 pi over 4. And in case you're not sure what I was doing over there, I was saying, well, this is 2 pi. This is 360 degrees. We're looking at just pi over 4 down here. So actually, I shouldn't label the reference angle as 7 pi over 4. This whole thing is 7 pi over 4 to get to this other angle. So we just found out that x is pi over 4, and x is also equal to 7 pi over 4. Now that's what x is. That's not what theta equals, right? Theta is 2 pi. So we could put, 2 pi, sorry. That's what x is. X is equal to 2 theta, I should have said. I don't know where pi came from. X is equal to 2 theta. So we need to plug 2 theta back in, and then we can solve these smaller equations. Okay. One equation when 2 theta equals pi over 4. To solve that, you would get theta equals pi over 8. And then do another equation where theta equals, where 2 theta equals 7 pi over 4. So that would be 7 pi over 8 when you solve that one. So these are 2 solutions, and you actually need to check. There could be more solutions because of the 2 that's next to theta. Okay? So one thing you want to do is let's take x, and let's think of coterminal angles. Like we have pi over 4. If we take pi over 4 and we add 2 pi to it, we're still in the same place, right? Get common denominators, that's 8 pi over 4, so that makes 9 pi over 4 here. That's still the same angle as pi over 4, it still has the same terminal side, but maybe now if we plug 2 theta back in for x, we'll get a new solution that's within our interval. X can also equal 9 pi over 4, and if you plug 2 theta back in and solve, you get theta is 9 pi over 8. So that's another possible solution because that's within the limits here. That's between 0 and 2 pi. 9 pi over 8 is between it. So you want to just keep checking those things. X equals pi over 4. Let's see if we go 4 revolutions, if we have another solution. Because look, pi over 4 is the same thing as pi over 4 plus 4 pi, right? Because that just means take 2 revolutions from where pi over 4 is and you end up in the same spot. So if we simplify this, that's 17 pi over 4, and if you plug theta back in for x and solve, let's see if we get another solution within our the restrictions of our solution area between 0 and 2 pi. If you solve there, you get theta equals 17 pi over 8, and so that is actually a little bit bigger than 2 pi, so that's not a potential solution. Okay. Do the same thing with your angle of 7 pi over 4. X equals 7 pi over 4. Let's add a full revolution to it. We'll end up in the same place. So if we get common denominators, that's 9 pi over 4. That sounds familiar. No, sorry. That's my bad handwriting. That's a 7. Okay, so 8 pi over 4 plus 7 pi over, that's 15 pi over 4. 4, 8. no, that's definitely bigger than 2 pi. So that's not a potential solution. Maybe if we try to back up, if you try to do 7 pi over 4 subtracted by 2 pi, it's going to give you negative pi over 4. And we can't have any negative numbers. So we found 3, okay? This one, and this one, 9 pi over 8. So this one, pi over 8, and 7 pi over 8. If you're having trouble with this, using software like Desmos, it doesn't really practice the algebraic skills with trigonometric functions because you can get by without it, but you could at least use it to check and see, did I miss a solution? But that part is the part that usually haunts students, is where you got to check your answers for x. Go back, you solve for theta, you get 2 answers, but then go back to your answers for x. If I add 2 pi to it and plug theta back in, does that give me a new solution? And in this case it did. Same thing for this one. Let's get cosine by itself. So we get cosine pi over 5 theta equals the square root of 3 over 2, and we'll make that substitution that x is pi over 5 theta. So now we're dealing with cosine of x equals the square root of 3 over 2. Same quadrants as the last one. And so square root of 3 over 2 needs to be on the adjacent. That way, the adjacent divided by the hypotenuse is 1, because that's the definition of cosine. So if this is square root of 3 over 2, then that means this has to be 1/2. This is just going from what our special triangles say. So this is pi over 6 for the first angle. X equals pi over 6. And then we also have, let's see, 12 pi over 6. That's 11 pi over 6 for this angle, right? That's because that's 330 degrees. So you could double check that just to make sure. 330 divided by 180. Wait, that's 11. Oops. Oh my gosh. Yeah, okay, checks out. So pi over 6 for 30 degrees, for the 30 degree angle, and then 11 pi over 6 for the 330 degree angle. So those are 2 solutions for x. That's not solutions for theta though, okay? These are just going to be our key solutions that we're going to use to try to find all the other options. So let's start with the most basic one. Let's plug pi over 5 theta in for x in the first equation, right? X equals pi over 6, so I'm going to plug pi over 5 theta in for x. And then to solve for x, I'm going to solve for theta, I'm going to multiply by the reciprocal. I don't think I'm saying anything right today. Multiply by the reciprocal. So I get theta is, cross cancel, theta is 5 over 6 for one of our solutions. Let's do another one. Let's plug pi over 5 theta equals 11 pi over 6 this time. And if you solve that equation by multiplying by the reciprocal, the pi's cancel out. So you get 55 over 6. But now we need to think about all the other angles that are coterminal with pi over 6. So like x equals, I want a different color. X equals pi over 6. What are our restrictions? Probably 0 to 2 pi. Yep, 0 to 2 pi again. If we add 2 pi, we're still in the same place. So this is 12 pi over 6. So that gives us 13 pi over 6. Let's see if this gives us another unique solution. If I do that for pi over 5 theta equals 13 pi over 6, because that's what x is. It's pi over 5x. And we solve this equation. We'll multiply by the reciprocal. The pi's will cancel out. So we're going to get 5 times 13 in the numerator. That's 65 over 65 over 6. And let's see if that's beyond our limits. 2 pi was as high as we could go. So if we do 2 times pi as a decimal, 6.28. If we do 65 divided by 6, yeah. So this is out because it's too large. It's above 2. Man, I hate that thing. It's above 2 pi, okay? Yeah, so I think all the other ones are going to be out too. If you try to, so if we added 2 pi, that gave us a solution that was too big. If you had 4 pi, you're definitely going to get another solution that's too big. And same thing here, if you add 2 pi to this, well, if pi over 6 plus 2 pi was too big, then 11 pi over 6 plus 2 pi is definitely going to be too big. Okay, so 5 over 6 is a solution. Then we also had 55 over 6. I didn't check that when I did that one. Why didn't I? 55 divided by 6. Oh, because, man, good thing I checked this last part. Look, 55 over 6 is also too big. If 2 pi is our limit, if you do 2 times pi as a decimal again, that's 6.28. If you change 55 over 6 to a decimal, that's also too large. So there's only one solution in this region.